Hello guys, welcome to Self-Help Maths Academy. In today's discussion, I'll be talking about method of U-substitution. So how do we exactly do the integration by using the substitution method? So what is this method is all about, and how do we solve the examples? That will be our today's discussion. So in this particular method, the method of the U-substitution actually involves the two terms. Okay, so one term is the constant multiple of other term. Okay, I mean the constant multiple of the derivative of the other term, the derivative of the other term. Okay, so here there are two terms. One will be the derivative and one will be the term. Okay, so there are two particular terms will be involved in this. So this method works by performing the steps like we are going to let u will be your other term. Okay, so there are two terms, as I told you. One term will be there and its derivative will be there. Okay, so that one term, I'm naming it as other term. Okay, so its derivative will be there. So therefore let me introduce u as the other term. Okay, then you're going to rewrite the whole integral. You're going to rewrite the whole integral in terms of u, and then you have to integrate and express in terms of the original variable. Okay, so we'll be doing this in terms of the original variable. So it involves three steps basically. So we need to as I told you, it is having one term which is the constant multiple of the derivative of the other term. Okay, so there are two terms now. Then whatever the other term is there, that will be substituting as u. Then you will be rewriting the whole integral in terms of u. Then we need to integrate it and express in terms of the original. Okay, so let's see with the example, it will be more clear. So the example which I am considering now, say let me take integration of say 48x into x square plus 5 to the power 11 into dx. Okay, now in this, if you observe carefully, here you have got a term involved x square. Okay, and you also have a term which is like x. When you observe both the terms, we know that differentiation of d by dx of x square is basically 2x, means it actually includes the term x, and that means here we have got the other term which is x square plus 5 and its derivative which is in terms of x, that is this term. So when you are substituting the value as u, please make sure that you are taking the other term. Okay, so now here I'll be putting the first step is let, you can take this as step 1. I'm writing let u is equal to x square plus 5. Okay, this is my first step. I'm just substituting my u as x square plus 5. In this case, my other term is x square plus 5. And then differentiating this. So we'll get du with respect to x. I'm differentiating du or dx is equal to 2x. This is x square, that is 2x, and the constant differentiation is 0. So as I think we should know now, that is d by dx of x to the power n is n into x to the power n minus 1. So I'm using this formula. Here my n is 2 in this case, so therefore it will be n into x to the power n minus 1. So now I've got this. We can write this as du is equal to 2x into dx. So here if you observe carefully, in this case I have 48x, like in the integral when they have given here, it is 48x dx, but I have got here 2x dx. So in order to get this 48 here, I have to multiply both the side with 24. Then I'll get this 48. So let me multiply both the side with 24. I'll get here 24 du is equal to 2 into 24, that is 48x dx. Okay. So now this is all done. Now let us substitute in the original integral. So now this will be integral x square plus 5. I have taken that as u. So it will become u to the power 11 is there. So this will be u to the power 11, and 48x dx. As you can see, 48x dx will be my 24 du. So that is 24 into du. Okay, so now I can take this 24, which is constant, out. So 24 I have taken out. So this is simply u to the power 11 into du. Okay, so this is again in the form of x to the power m. I can use the integral formula. So this is u to the power 11 plus 1 over 11 plus 1 plus the integral constant c. Okay, so I can write this as 24. This 11 plus 1 is 12. Okay, this is u to the power 12 plus integral constant c. So I can cancel here. This is 12 times of 1 and 12 times of 2. So I'll be getting here, this is 2 into u to the power 12 plus c. So as I told you, after doing the integration, so we have to integrate and express in terms of the original. So my u basically is nothing but x square plus 5, which I have considered. So therefore I'll be writing this as equal to 2 times of my u is x square plus 5 to the power 12 plus the integral constant c. Okay, so now again we are going to rewrite this as the original form. So this is the answer for this particular integral. Okay, so now let me take up another example. Okay, so in this case you observe here we have integral 3x divided by square root of x square plus 1. So here also we have got a term which is involving x square, and we have got a term which is x. So therefore you know that differentiating x square you will get the x. So my other term will be x square plus 1. So therefore let me put now, let u is equal to x square plus 1. Again you differentiate this with respect to x. So differentiating will give me du by dx is equal to 2x. Okay, so I can write this as du is equal to 2x dx. Now if you observe carefully, here I want 3x, but I have got here 2x. So for the easy understanding, now I don't want this 2, so let me divide throughout by 2. So when I divide throughout by 2, so I'll be cancelling this 2 here. So this is like 1 over 2 du, which is equal to x into dx. All right. So now here what I've got is x dx, but I want 3. So multiplying both the side with 3 now. So I'll be getting here 3 over 2 du is equal to 3x dx. So I've got 3x dx which is required. Now consider the original integration, the integral. So that will be converted in terms of 3x dx is your 3 over 2 du divided by x square plus 1 is u. So that will be now square root of u. Okay. So now this is equal to, this 3 by 2 is again constant. So take it out, 3 by 2, and this is integration of. So this is nothing but square root of u is nothing but u to the power 1 by 2. I'll just take it up. This will be u to the power negative half into du. Again x to the power m formula I'll be using. This is equal to 3 over 2 into u to the power minus 1 by 2 plus 1 divided by minus 1 by 2 plus 1 plus integral constant c. So this is now equal to 3 over 2 u to the power 1 by 2 divided by 1 by 2 plus some c. Okay, so here after the further calculations, so here we have got 3 by 2 u to the power 1 by 2 1 by 2. So this 1 by 2, if I take it up, this will be 3 over 2 into 2 over 1 into u to the power 1 by 2 plus integral constant c. So I can cancel this 2 here. So you'll be getting 3 into u to the power 1 by 2 plus c. So originally your u, when you're substituting, it is x square plus 1. So please rewrite now the this as the original value, that is now equal to as the 3 into, this is x square plus 1 to the power 1 by 2 plus c. So this will be your final answer. So usually in the basic, rule of the U-substitution method is, you have seen that we are taking the terms. It involves two terms. Basically, it has the derivative. Also, it has the other term. So you'll be taking the other term as u, and then you'll be differentiating it. That is your step 2, and then you'll be writing it as again everything, if the whole integral in terms of u, then you'll be integrating it. Finally, once you get the value, you'll be getting it back in terms of the original integral, okay, or in terms of the original variables. Okay, so let me take another example of the substitution method in the same way. Like you have something like, say, integration of e to the power, say, tan theta upon cos square theta into d theta. So in this particular problem, if I can write this example as, say, e to the power tan theta, 1 over cos will be secant square. I'll write this as secant square theta into d theta. So here also we know that we have the function tan theta. We also have the function secant square theta. We know that the derivative of tan is secant square. So hence I can substitute my u as tan theta. So let u is equal to tan theta. So differentiating, I'll get du, since my variable is theta here, du with respect to theta is secant square theta. So therefore du is simply secant square theta d theta. Okay. So now what we get, we will be rewriting this integral in terms of u. So integral is equal to e to the power u, and your secant square theta d theta is nothing but du. We know that exponential integration. So integration of exponential function, if you have integration of e to the power ax dx, this is exponential function itself divided by the coefficient of x. So the coefficient of x is a here, so that will be a. Similarly, here this will be the e to the power u itself, because there is no coefficient of u here, so this is just simply plus c. So since the u which you substituted is tan theta, so therefore it is e to the power tan theta plus integral constant c. So this will be your answer. This is how you will be using the substitution method in order to solve the examples. So this is for the substitution method, guys. Some more examples will be solving in the upcoming videos. Thank you.